Hi everyone. In today's challenge, we are going to solve this problem. The problem name is Tallest Billboard and the problem number is 956. Alright, guys, so as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem. What is the logic to solve this problem? And after that, we are going to move to the implementation part. We are going to implement our logic in C++, Java and Python programming language. Fine guys, now let's see what this problem is, right? The problem says you are installing a billboard and want it to have the largest height. Okay, so we are going to install a billboard. Fine, and the billboard will have two steel supports, one on each side. Each steel support must be an equal height. So they have told that the billboard is going to have two steel supports. So let's say this is the first and this is the second, right, so S1 and S2. Now they should have equal height, that they have clearly mentioned, right? You're given a collection of rods that can be welded together. For example, if you have a rod of length 1, 2 and 3, you can weld them together to make a support of length 6. So collection of rods is nothing but you can say array of rods, right? Same thing, right? Array of rods, that means we are clearly mentioned that what is the input. Input is going to be nothing but array, where the value is nothing but we can say rods, right? So we can weld them together to make a steel or anything, right? Okay, now return the largest possible height of your billboard installation. If you cannot support the billboard, return 0. So now guys, what we have to do, we have to return the largest possible height of our we can say billboard installation, right? So simple thing guys, the first thing they have mentioned that they should have equal height, right? Here you can see on each steel support must be an equal height, so they should have equal height. So we have to make steel by welding these rods such that they will have equal height, right? And the second thing is nothing but we can say we can weld them together. If our roads array look like 1 2 3 4 5 6, so we can weld them 3 and 5 and 6, 1 2 and 4 on the one side and 3 5 and 6 on the one side, means we can take any number on the left and right side, right? So that they have mentioned, right? The third thing is that you don't need to use all the roads. You can leave some road as well, right? If you are not able to make equal, so but you have to make equal, you can leave some road as well, right? And the fourth thing is nothing but if we could not able to make equal these roads, right? If we could not able to make two steel equal, two steel support equal by using a roads, then we are going to return nothing but 0 only, right? That means the height is 0, means it we could not able to install it, right? I hope it makes sense. So let's understand this with examples so that you can have better understanding. I know by the statement you would not have a better idea. So let's see the example one. Here we have, you can see we have given a collection of rods 1, 2, 3 and 6, right? Now what we are going to do, we are going to say, okay, so I want to make a two steel support, right? So first is initially empty, second is also initially empty, right? So let's say I put one here, fine, and I put two here. So will this make sense? If I do this, so they are not same, right? We put three here, or let's say 3 here, 6 here. So still they are not making equal, right? This is a 4th length, this is a 8th length, right? But what if we can say we are putting 1 here, 2 here, 3 here, so length is 6 and we simply put 6 rod here. So you guys can see that both steel support now going to have a same length, right? So here also 6 length, here also 6 length. So we are going to say the maximum, or we can say largest height of the installation, we can say is going to be nothing but equal to 6 only, right? So we are able to make the steel support length equal to 6, right? I hope it makes sense, right? Now let's move to the next example so that you can have a more better understanding. We have this array 1 2 3 4 5 6, simple thing, 4 5 6. Now this is the both steel support, right? Try to understand in this way. We are putting one here, and let's say two here, three here, four. No, it's not gonna work. So what they have done is nothing but you can see in a line 2 3 5 and 4 6 on the one side, 2 3 5 4 6 on the one side. So as I have already told you that we can leave some nodes, so we have removed this one, we haven't taken one node, right? So 2 3 5 is nothing but you can see 10, 6 4 is also 10, right? So we are going to say nothing but the largest height we can get of a billboard installation nothing but 10 only, right? You can see both the lengths are equal here, and we have used all the not all the length, but we have used only these numbers which are present in our roads array, right? So we can say largest is nothing but 10. You can see in the output as well we have a 10, right? Now let's move to the next example, that is nothing but you can see 1 and 2, right? So guys, we have only two things, 1 and 2, right? And this is left first steel support, this is second support, right? So we insert one here, we use a root 2 here, still not same, right? They are not equal. But if we do like this 2 and 1, it's still not equal, right? So that means we can use any combination, but still road is not going to be, these two supports is not going to be equal, right? So what we can say, if it is not the case, so we are going to return nothing but 0 only, right? I hope it makes sense. So that was the simple logic, guys. I hope you understood. Not logic, I would say problem statement. I hope you understood the problem statement here, right? What we have to do actually, what the problem wants, right? So it's nothing but it want a largest maximum, or we can say the highest length of the your billboard installation, right? Which will be nothing but the length of the any of the supports, right? Either length of the supports, only the support, but these two supports should be equal, so we can take any length of any support, right? And let's move to the logic part, see how we can solve this problem, right? We have understood the problem statement, so that was not a hard thing, but yeah, logic is going to be really hard. Not really hard. We are going to solve in a just, you can see guys, if you have understanding of recursion part, right, then you can easily solve it, right? We are going to use nothing but dynamic programming, nothing else. And why it is so, we will see it later, but you should have a better understanding of recursion, how it works. If it you don't have, don't worry, let's try to understand from here, right? Maybe you can get a better understanding by this particular problem, right? So how we're going to use a DP here, see guys, let's take a first example only, 1 2 3 and 6, right? So initially what we will say, okay, we are starting from zero index. Remember, we are starting from zero index, and I will say I have zero, I'm currently on zero index, right? And I have a difference is also zero. Think about what is the difference. We will discuss it later. But think about, I am at zero index and I have a difference is zero, right? Now what I'm gonna do, I'm gonna say on the zero index, three possibilities are there. Either I can take it, I can take it in first road, right? So I can say I will reach to the first index and I have take it, so my difference is gonna be nothing but one, right? So difference is nothing but one. But the second possibility is here that I can leave it. I don't want to take it. Or I am taking it but taking it for another road, for another support, right? So there are two supports, right? This is the first one, this is the second one, right? So we have to make both the equal. So it may be the case that I'm taking it for the second support, right? I have taken it for this one, I have taken it on the left side, but here I'm taking it for the second support. So I'm indicating with the minus one. I'm going to subtract it, right? The third option is going to be nothing but I don't want to take it. So I'm still at one. I'm still at difference zero, but index is one, right? So now here I reach to the one index. On we are going to move to the next index only, but there are three possibilities to move to the next index. Either you can take it for the left supports, either you can take it for the right support, either you cannot take it. Either you are not taking it, right? You are moving directly to the next road. You don't want to take it, right? Now for this, what we are going to do, we are going to say, if we have taken it, right, here also you have three options. Either you will move to the second index, right? That is for sure, you will move to the second index. Either you want to take it this second, right, length of 2. Okay, I want to take it, so I will say 1 plus 2 is nothing but going to equal to 2, or not, 1 plus 2 is going to be equal to 3. Either I want to take now this for the right side, right? So I will say subtract 1 minus 2, which is going to be equal to 2 minus 1. Either I don't want to take it, so I will say 2 comma 1 only, right? So what this indicating that on the second index you have difference 1, on the second index you have difference minus 1, on the second index you have difference 3. Is that making a sense, right? Just tell me if you are getting it or not, because I believe that you know the recursion how work, but still if you're not getting, so that means we are taking each and every possibilities on each index, right? So we have currently three possibilities, right? So we'll do the same things for 2 comma 3 as well. So either I will take it or not take it, right? Or I will take it for the left side and right side. So let's say I will reach to 3 index and I have take it, so this 3 comma plus 3 is going to be 6, right? You can see we are at third index. So on third index, you can say we have three value. Means the length of road is 3. So I have taken it, so it's going to be 3 comma 6. I don't want to take it, so I will move to third index. I will want to take it for right side, so I have to subtract it. So it's going to be nothing but equal to 0. And I want to don't want to take it, right? So that's the difference is going to be remain same, right? We'll come to again this 3 comma 6 part. So let's me go to this. So for 3 comma 6, what I'm going to do, I'm going to say we have three possibilities. So let me make it above. So for here, either I'll move to the fourth index. That is make sure, right? We are going to move to the fourth index. What I'm going to do, I'm going to say either I am going to take it for the left wing. So then I have to add 6. So 6 plus 6, 12. I want to take it for right wing. So I'm going to say 4 comma 0. I don't want to take it only, right? So 4 comma 6 only, right? Now 4 comma 6, I will not able to move anywhere, right? So length is over, right? So it's going to return something. It's also going to return something. It's also going to return something, right? Now we have drawn the recursions. We are going to not draw for the rest of the parts because we know that the answer is not going to be there, because this was the example. But you have to draw all each and every possibilities. But here we are going to get answer here only, right? So what I'm going to do now, whenever we got the we can say the last of the our we can say array, or we can say last index. So here you can see fourth is the last index, right? Now we are going to move to the we can say a fourth index, but fourth index does not exist, right? You can see the length was only 4, so we can have only 3 index, right? Till 3 index. So once we reach to the 4, we gonna say if you are having a difference anything not 0, then we are going to return nothing, minus 1, or you can say the least thing, right? Into minimum, or we can say float infinite, nothing, but you can say anything, right? But not large, we can say the largest negative value. In Python you can use a float infinity minus infinity. In C++ you can use int min. In Java you can use integer dot min value, right? So you can return anything, but if you're getting a value 0, that indicate that, all right, so that what that tell you that yeah, we can make our that particular thing, we can say our two supports still equal, right? So this is going to tell us 0, right? So that means we can make a support still equal to you now. And this 4,6 is going to nothing but it's going to also tell us that we are going to return a negative number, least largest negative number of array. So whenever you're getting a 0, that means you can able to make a support still equal, right? So how we are going to get a length now, because we have to return the length, right? So we're going to say whenever we are taking, we are going to add that particular length, right? Now come to the top again and start taking it. So we are going to change the color. See guys, I have taken a 1, so I'm going to add 2 here. I have taken a 1 here as well, so I have even I have taken on the left or right side, doesn't matter, but I have taken it, right? So I'm going to add 2 here, and I'm not going to add anything, so it's going to be 0 only, right? So here again come, I have taken a 2 here, so 2 plus 2 is 4. Okay, so sorry, here it should be 1, here also it should be 1, because we have taken a 1, right? So we are going to add 1 only. Now I'm going to take a 2, right? So I have to add here nothing but 1 plus 2 is 3. Here also 1 plus 2 is nothing but 3, right? So from 1 I have taken 2 as well on the right side, but here we are subtracting it, doesn't matter, but I have taken it, right? So we are going to say 3. Now come to this side. From on this side, on second index we have taken, right? 3, we have taken the 3. So 3 plus 3 is nothing but 6, right? Here it's going to be 3 only, we are going to add it. Here also it's going to be 1 only. Now here we have taken a 6, right? So 6 plus 6 is 12 here only 6, right? So you can see where we are getting a 0, we are going to return nothing but 12, we are going to have nothing but 12 only, right? So we are going to say the total length is going to be nothing but 12, right? And you know that guys, total length is 12 and we are converting into total to support, right? So we are going to say total we have 6 and 6, right? So we are going to return nothing but 12 by 2. Always we are going to return divided by 2. I hope it makes sense. So always whenever you are getting a 0, you are going to return 12 by 2. And here if you will notice, we are also getting somewhere 0 here as well, right? So that means there was 6. So that means we can also make a support of 3 length as well, right? But we are going to return highest one. That's why we choose a 12. We keep exploring. So we are going to use take a maximum of all these and we are going to return divide by that. So 6 and 12 maximum is going to be 12. So 12 by 2 is nothing but 6. So our answer is going to be 6. I hope you have understood this logic part. So that was the simple, we can say, recursion. Now we are going to see how it's going to work, right? It's always going to return a TLE. If you will right now go to the we can say browser and start solving implementing this will going to return TLE, because every time you have three possibilities, right? So each time three possibilities, the length of, let's say the array's length is n, so n raised to power 3 or 3 raised to power, I'm not sure, I'll check it, but this is going to be give a TLE, right? I hope it makes sense. So this is going to be always 3 raised to power n, I guess, right? So this is always going to tell you, but how we can memorize it? We can memorize it by taking the index of, by taking this particular index and difference, right? We can, you can see this pair can be repeat again and again, right? So we are going to use a memorization on this particular we can see key and index, and after that we are going to return if we have already explored that particular part, right? So that's the particular thing we are going to do. We are just going to memorize it, and this will become a DP, dynamic programming, and we are going to solve our example with this problem, right? So let's move to the implementation part and let's see how we can use this recursion and how we can memorize it, right? So guys, what I'm gonna do is I'm gonna go to this browser. Let's go here, bro. Right. So let's increase the size first of all, not 175, bro. Fine. So we have 125%, right? So first of all, I'm with the Python, right? So let me tell you first of all by making a function define sol. Here, what we are gonna do, we are gonna say it's gonna have first of all index. What happened to it? Okay, and then it's gonna have nothing but difference, right? And here we can say if our index is equal to length of this road set. So let's calculate length here as well. N is equal to length of roads, right? If we are come to the last of our array, right? Last index. So we are going to say check it if difference is 0. So what you're going to do, you're going to return nothing but we can say 0, right? If difference is not 0, then you're going to return floating field. See, I'm doing like this way to understand you, but you can use a conditional operator which is going to work here, right? So if like let me show you also how. See, here you can do like this, difference is equal to 0. If it is the case, then what you're going to do, you're going to return 0. Else you're going to return float of infinite, right? And I have used some difference here, but I have to do here, right? I would make sense. So you can do like this way as well. If just try it, I'm thinking that it will work, right? But let's see, right? Now after that, what we are going to do, once we we are at not, we can say we are not at the last index, we are in between. So we have three possibilities as we have seen, right? So we have three possibilities. Either we can take it on the left side for left support, for right support, or we are not gonna take it. So we can say return maximum. We are gonna return a maximum out of these, right? So first maximum is gonna be nothing but sol index plus one. Always index is gonna be increased, right? You are gonna take it for the left side. So you are gonna say difference plus rows of that particular index. So this is going to be nothing but we are going to add for the left side. So that's why we are adding it plus rows of index. So what is this plus? We have already seen, right? Every time we are adding it. If we are adding for the left side or right side, we are going to add that particular we can say value also. So now let's add on the right support. So row we have support. We have to mind subtract this, and this means we are adding for the right support. Then we are going to add this row index, right? After that, the last option we are not going to take it. So we can say index plus one difference is going to remain same, and we are not also going to add this row index also. We are not taking it, right? So this is the basically we are going to do. After that, we are going to call this function for zero. We are starting from zero index. We are having initially difference zero, and after that we are going to divide it by two, right? Before returning it. So let's run this code and see whether it's working fine or not, right? And I hope guys it should work. But it's saying that solve is not defined. Yeah, it's not defined because we have used a different. Now let's run this code. Hopefully it should work. We don't want to see any more error. You can see guys, all the rescues pass, right? But first of all, let's check this as well. It should work, right? What happened to it? Let's see. It's not working. Alright, so I think we should do like this. If it's not working, then try to use the work case only. I thought it should work, right? We'll try to use it in this way. Alright, so let's comment this. We are not going to waste much time on this. Let's run this code, right? So guys, you can see all the test cases are working, right? Currently, but this is a brute force approach. It's not going to work for the test case. If I show you by running the test cases, so you can see we are going to get a TLE. Definitely we are going to get. Let's see. Just give a TLE. You can see guys, it could not able to pass the seventh test case, right? So what we are going to do guys, we are going to use a memoization, and in Python we are going to use a function tools, right? Function tools. What is this? I don't know. Function tools dot LRE cache. What this is meaning is nothing but least recent used cache, right? Here we are going to use this particular thing, and let's run this code and see whether it's fine or no. Func tools, right? Okay. First of all, let me go to solution. Not solution. We can say submission. Let me copy this test cases as well. I'm just doing for this particular one. For the next problems, we are not going to do this. We are going to directly do the implementation, right? But for this, I want to just show you how this working, right? For test case, what I'm going to do, I'm going to add this one and let's run this code. It should pass, right? So let's check it. So you guys can see the four test case also got pass. So we are going to submit this one. So what this function tools.lre cache does, it is nothing but a decorator, right? Here we don't need to use any, we can say, hashing or anything. It by default gonna do the tasks, right? It's gonna see if we have already passed this parameter in this function, so directly written from the cache. Don't be, we can say, don't try to call this function again and again, right? So this is nothing but one way of using a memoization in Python. But in C++, Java, we don't have this, I guess. So we are going to use it manually, right? So I'm with the C++. First of all, I'm going to get the length, road lengths. After that, what I'm going to use it, what I'm going to do is, first of all, I'm going to define a map, right? Here we can't use a function root or LRE cache. So we are going to say map of pair int and int. Here we can say dp, right? After that, call that function sort and pass this zero index, zero difference, length is roads and dp, right? After that, we have to return by divide by 2. So let's define this function as well, right? So I'm gonna do nothing but public, not public. We can say directly int sol. It's gonna take a first of all the index, then we can say int. Here we can say difference, then we can say n, then we can say vector of roads, right? Vector in we can say roads, and the last thing is nothing but this map, right? So let's just copy this particular thing. We don't want to write again and again, right? Okay, and we have to use up what happened to it. Let's copy again, right? So guys, we are going to use a pass value, right? Now once this is done, we are going to do nothing but we are going to check first of all one condition. If that particular we can say this index and difference is already we have explored it. That means if dp dot find this particular thing is not equal to end, right? Not equal to dp dot end. So what I can say, I can say return dp dot these things, right? dp of idx comma difference, right? If it is already we have explored it, so return directly this. But if it is not the case, that means we have to explode it, right? First of all, check if n is equal if idx is equal to n, that means the last index. So first we have to return that particular thing. If difference is equal to 0, we are going to again try this, right? Difference is equal to 0, we are going to say return 0. Else what you are going to do, you are going to say return integer min, right? Fine. But if index is not equal to n, then what you are going to do, we are going to say return the maximum one, right? Return maximum. Here we can say first of all call this function solve index plus 1 difference plus this particular rows of that particular index and comma n comma rows comma dp, right? So here we are going to add this particular thing, rows of idx. So this is for the left support. Same thing we are going to do for right support as well. So let's copy this thing. The only thing which we are going to change is nothing but we are going to subtract it, right? Nothing else we are going to do else, subtract it. Okay, and here for the last one we are not going to take it, right? We are just saying that what happened to it, right? So now what we are going to do, I don't know. All right, so we are going to say sol. Here if we don't want to take it, we will move to the next index, but difference is going to remain same, n is going to remain same, and road is the same, dp is also same, right? So once this is done, we are going to set this, but this will also give an error because max function don't take 3 argument. We have to use inside also max function, right? Fine. Now we can simply do this thing, but it's still we haven't memorized it, so we can say store in somewhere, right? So we can say dp of idx and difference store in this, and after that return this only, right? Return dp of idx comma difference, right? Let's run this code, and I hope it should not give any error. We don't want to see, but we get it, right? Road stored length, it's not Java, it's C++, so we have to use the size. Finally, now let's see whether it's working fine or not. Pass. You can see guys, for the all the test case pass. So let's try to submit this code as well, right? So that means this conditional operator is working in C++, right? But in Java, it's, in Python, it was not working. So we'll see it later, right? So you can see it successfully got submitted. Now let's move to the last programming language, that is nothing but Java. So in Java, what we are going to do, first of all, let's take a length. Int n is equal to road length, and then we are going to define a hash or map. So let's define it at the top. Map in, we don't have pairs, so we are going to use integer, string and integer. And here we can say name dp is going to be nothing but new hash map, right? Once we have defined it, we are going to find a function as well. That function name is going to be nothing but equal to, we can say sol, and here we can say 0 index, 0 difference currently, length is n, rows you have to pass, nothing else you have to do, right? Because map we are taking globally, then we have to return divided by 2, right? So we are going to return directly here as well. Fine. Now what I'm going to do, I'm going to say fine. Here just define a one function public int sol. This function is going to take a first of all index, then int difference, then int length, then we are going to say rows, right? So int rows, right? Once this is done, we are going to say if first of all let's create a key, right? As we are using a key, string key is going to be nothing but index plus like this, and we can do this, like this is going to be always unique key for each index and difference, right? So we are going to say if that key, if dp contains key, this key, this key is contain, let me write key, right? Fine. If it is contained, and then we are going to return dp.get this key, right? But if it is not the case, then we are going to say if check it, if index is equal to n, so you have to, what you have to do, you have to use that condition operator, return 0. We are going to return 0 and not return 0. We are going to check if difference is equal to 0, so we are going to return 0. Else we are going to return a integer dot min value, right? Fine. But if it is also not the case, so we are going to calculate the maximum one. So we can say int result is going to be nothing but math dot max, and here we can say sol. You have to increment index always. Difference plus load of that particular index means we are going to add that particular load on the left side. Then you're going to pass same n, same roads, and then you're going to add also roads of index, right? So this we have done for the left side. Same we are going to do for the right side. And here just one thing we are going to do, which is nothing but difference minus road of x, means we are going to add for the right side. After that we are going to say sol index plus one, difference, and rows, not rows, and rows, right? We don't want to take it. So when this is done, we are gonna add, but here also we need to use a math.max because math.max don't take three argument, right? Fine. So we have done these things. So here we are gonna first of all say dp of put this particular key result. Then you can say returns directly result, right? Now let's see whether it's working fine or not. I hope it should work, right? But no, always we are getting every time an error. Difference is string. You cannot find a symbol. What symbol you are not able to find it? Okay, string spelling. I don't know what's happened to me. Do we have any more error? Let's see. Okay. dp dot contain key contain d. What's happening? Typo error. So you guys can see that, right? All the task is passed here. So let's try to submit this code. And I hope it should also get submitted, right? So you can see guys, it successfully got submitted. So we have successfully solved with C++, Java and Python. We have seen the problem understanding part. We have also seen the logic part. If you have any kind of doubt in this section, you can write your we can say comments in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet in the next video.